Welcome to round 2 of the physical simulation. In this simulation, we're making the transition from the unit cost equation mindset to thinking in terms of Kaizen and solutions that we can use to make improvements to the manufacturing system. This round of the simulation focuses on more of a point Kaizen single solution approach in which we are demonstrating the implementation of MRP to address production requirements, and also the use of mistake proofing or Poka-Yoke devices for parts incoming to assembly. Next, we summarize the observations from round 1 and also the countermeasures that we're putting in place in round 2. Countermeasures are the implementation of an approach to address the concerns that we observed in round 1. So first of all, the supplier did not know how many parts to ship to assembly. So the countermeasure is to use material requirements planning, forecast calculation to determine the number of large green Legos, for example, to ship to assembly. In the case of the green products, we need a total of 8 good green products. So the bill of materials says that we need 2 large green, so we need a total of 16 large green Legos. Next, with MRP, there's an important idea of uplift. MRP is attempting to provide an uplift or overage of parts to ship from the supplier to assembly based on the average number of defects in the supplied parts and the average number of defects after assembly. The number of defects after assembly we're going to assume to be 10%, and the number of defects that are shipped from the supplier is 1 in 6, or about 16.7%. Secondly, we are deciding to ship, based on this calculation, 4 containers of each color and size of Lego according to the round trip time. Second observation is that, as you know, we didn't get the 8 red, 8 green, and 8 blue. In fact, we didn't meet the requirement for any of the products, so that's also the foundation for implementing ERP and scheduling the supplier to push products to assembly. Third, defects are going to the customer, which is a fundamental issue that a manufacturing company would not like to have happen. Sometimes these are called escapes. So what we have done in one regard is to quit assembling the defective incoming parts from the supplier. Those incoming parts are signified by the yellow Legos. We have installed a magic Poka-Yoke device that we are simulating, whereby the assembler can see the yellow Legos and pull those out before assembling the product. In practical terms, this could be a device that detects the attributes of a product before it's assembled, like the diameter of a product, or in electronics, the capacitance of the capacitor. Fourth is that we realized that we had defects based on functionality of the product, so we've implemented a full functional test to ensure that products do not escape from assembly to the customer. This could be like a leak test in hydraulic steering gears, or a full functional test in electronics. Full functional tests are not desired, however, and our real goal would be to make the process capable enough so that we would not have to have a functional test. But in this simulation, we are simulating a defect rate of 10% in functional tests. The way this is done, which will be shown in more detail, is that we will draw with a probability of 1 in 10 defect from these small Legos. There's 2 yellow and 18 white Legos in this container that's drawn from. The final observation is that supplied parts delivery was occurring more often than actually practically possible. We have a true round trip time of 30 seconds, but the supplier was going back and forth much more often than 30 seconds in order to ship the product. So we came up with the idea of using a tray to carry all parts that were removed by assembly within the 30-second time interval, to take the empty containers back to the supplier every 30 seconds. Also, standard work is being implemented so that the 30-second cycle is followed every time, and the supplier arranged their layout to correspond to the assembly layout in terms of red, blue, and green product. And then finally, the sixth observation was that we were not balanced to tack time. One of the assemblers is idle most of the time, so we decided to reduce from 3 assemblers to 2, and Sarah was kept as an assembler since she was the person who was idle most, and Joe has now been moved to the functional test operation. Have fun watching the videos as we go forward. The final summary here is illustrating that we are using a push system where MRP is scheduling the supplier in terms of what to ship to assembly. So they're pushing the required parts as estimated by MRP to assembly in this round.
Hello everyone, I'm a supplier. I'll be supplying these containers with using this tray. As we did MRP calculation, I will be supplying 4 containers of each large and small Legos. And I will this time I will take in empty containers and I will put it on here. So once I'm ran out of the containers of these 4, I will get to know that I have shipped all containers. So that's it.
Well, this is Shahab, and my role stays exactly the same. So we now have a Poka-Yoke device, due to which we can now see the incoming defective parts, which is the yellow logo, and that's what we have designated this bin for. So it goes in here. The empty containers, rather than staying over here, has its own designated area, and the finished products go here into the assembled parts area for the inspector to check.
So I continue to do assembly, and it follows the same as Shahab, but unfortunately, because I was too efficient the first run, I now have red and blue to be doing. So yeah.
Well, I'm now the inspector. After round 1, we learned that lots of our products didn't function as the customer needed, and so we're now simulating a functionality test with these yellow and white Legos. So my role will be to take a finished product, and I will do a randomized test to see if it is good or bad. And if it is good, it is white, and it will go here. And if it is bad, it will be yellow, and then those will go on this side. Two, one. we just want to take a moment to explain what we saw in this round. We noticed that we're having a supply issue still. The assemblers are waiting a good portion of the time. And this round we used MRP to calculate how much raw material we needed to push through assembly to end up with 8 of each color at the end. If you notice here though, we only have 7 red and 7 green. And there's still some work in process in the assembly area, but there's not enough green to finish another product and there's no red inventory left. So we never would have achieved 8 of each color. And blue's a different story. Shahab can tell you about that.
So blue, there are 2 finished products, assembled products in the assembly area. Let's say we would have done inspection. One of them came out good and the other came out as, because of functionality test, as non-conforming. In that case, we would have ended up with ore production because we had 9, whereas the customer wanted 8. So the fact is, we'll always have this seesaw kind of scene where we have some underproduction, some overproduction, and we cannot achieve exactly what we want all the time with consistency.
So if we speed up the supplier, do you think MRP will work?
Well, no, because we cannot have no more product coming in anyways. We have only 24 parts of 24 Legos of each color and each type coming in, so we would always have ended. The only possibility is that maybe if these were not defective, we could have came in here, we would have ended with overproduction. If these would have came in here, we would have ended with underproduction on the blue, but nothing is.
So MRP can't account for extra or
Yeah,
less defects
correct.
here in inspection.
And that's the reality. At workplaces, it happens as assembly errors.
Great, thank
Yeah.
you.
So we saw in take 1 that the supplier was having issues and was potentially the bottleneck in take 1. So now we're going to ask the supplier to work faster. And our question is, if we use MRP, would that ensure that we obtain 8 red, 8 green, and 8 blue?
3, 2, 1.
So now we want to take a moment to discuss the end results and how did the simulation how did we perform. So as a customer, how do you see the end results?
I'm not very happy.
Mhm.
I don't want these. I only asked for 8 blue, 8 green, and I wanted 8 red, but I only got 6 here.
Mm.
So I guess if you guys would have ran a little overtime, maybe you could have gotten all of my red to me, or
Well, to that I would say we already ran out of time. I mean, we had extra time on us, 10 seconds.
then why didn't I get my?
Good question. So the thing is, based on our MRP calculation, which accounted for all the incoming defective material and all the assembly, which was supposed to be probability of 2 out of 20 defective parts. So assembly function test defective parts, MRP calculation had already accounted for it. So according to that, we only could ship as much as what we just did right now. 24 parts of each Lego color.
So there are red here, but these are defective, and
Yeah.
your MRP calculation didn't account for that many defective red parts.
Yeah, because MRP works on average, you know. So on average, we said there will be 2 out of 20 defective parts, but for some reason in our red assembly area, we ended up with more defective parts, functionality on functionality basis, and less on the green and blue ends. So this will always be like that. We cannot change it. It's a reality.
That's
Yeah, it's on average calculation.
sad to hear.
So in summary, with regard to round 2, and if we think about the 4 layers of the flame model, the tone was to just assemble the material that you're given if you're an assembler. And the thinking was that if we push the quantity of raw material from the supplier to assembly, assembly would be able to make 8 red, 8 green, and 8 blue. Sarah was the faster assembler, so we gave her 2 colors to assemble, and Shahab only had 1. Structurally, customer demand was still not met using MRP, even though we had the capacity to make 8 red, 8 green, and 8 blue. Much of that capacity went in making non-conforming products. And finally, no feedback from downstream operations, lack of communication from the downstream operation to the upstream regarding the products that were needed. So, in round 3, we will look at the systems approach to achieve 8 red, 8 green, and 8 blue.